Okay, so now we're going to make some modifications to this circuit, and rather than start over, what we're going to do is copy this entire thing. Now I'm going to leave this circuit just the way it is, make a copy of it, and just scroll down a little ways and paste it below the original. So what we're going to do now is add some automation to this. And rather than have a manual push button to do the retract, we're going to put a little automatic limit switch, a pneumatic limit switch, out here so that when the piston extends, it hits the limit switch and causes the cylinder to automatically retract. So first thing we have to do is to add a little end to the cylinder. So that gives the cylinder something to push, that it's going to push on this limit switch. And then what we're going to do is we're going to just modify the retract sensor. I'm just deleting the lines and just going to move it up a little bit. And I think I'll take out this retract label just because it's going to get in the way. So if I want to turn this sensor into an automatic limit switch, so to do that, the valve is actually going to have the same format. It's going to have the same paths and ways through the two sections. So if I double click this, I'm just going to replace this push button. If I scroll way down here to this, this is where the limit switches are. Click on this and click OK. And it comes up looking like this. And what I have to do is position this so that when, oops, I didn't want to do that. Just going to select it. I want to position this so that when that valve extends, it hits the limit switch. I think that's the right position. We'll find out when we run it. It's a little bit of, I can't really tell how far that valve is going to come out, but we'll find out. So this represents a little roller mechanism that when the pneumatic piston comes out and hits it, it pushes the valve down instead of a manual push. So I'm just going to reconnect the lines. When you're connecting lines with AutoSIM, whenever you want, if you just go to where you want to go, it kind of finds its own path. But if you want to determine the path for the line, you have to click every time you want a corner. All right, so that should do it. Let's just find out if this is in the right position. So I'm just going to run it again by clicking the soccer ball, and there it is. Okay, I guess I guessed right. So notice what happens now is I hit the button, it moves out, and then it automatically, when this pushes down, it shoots compressed air into this side of the valve and pushes it back to its original position. So this push button moves it to the extend position, and this one moves it back. Okay, let's stop the simulation. So I want to add something to make this a little more interesting. There are flow control valves that are designed in pneumatic systems to limit the rate of airflow and thus limiting the speed at which the piston extends and or retracts. So to get the flow control lines, right click, add an object, and under pneumatic there's a category for flow control, and the one I'm going to use is a throttle one way. They do have just the throttle valves, and they have a few that are fixed at 75% flow, 50%, 25%. There's a variable throttle that you can double click and adjust. There's also a check valve, but the throttle one way puts the check valve and the flow throttle into one component, so it just saves a little bit of time. It also is a little more compact. So I'm going to open that, and so I have to delete this connection and insert this in. And I have to put another one on the other side, and I'm just going to take this, copy it, and mirror it horizontally. Okay, now we're just going to connect those lines back the way they were. So if I run it now, it's not going to behave much differently than it did before. Maybe that's a little slower, I'm not sure. But if I really want to see the effect of the throttle valves, if you double click any one of these, you can type in the percentage of opening that you want. So if let's say I want this to be 40%, and I rerun the simulation, now notice how slowly it extends. So what's happening is, let's zoom in actually. So if you look at the way the throttle valve is set up, in parallel with it is a check valve. The check valve, this particular check valve, if the air's coming in this way, it's going to freely flow through that check valve. So the throttle valve is not going to have any effect. But the air flowing out will not be able to flow through this check valve, so it'll be forced through that throttle valve. So the reason this is done is so you can have separate controls for extend, speed, and retract. So if let me just go back a little bit. If you notice, right now the air is being forced through the second throttle valve, so the extend speed is affected. And if I want to affect the retract speed, let's make this 25%, really make it slow. And then we'll put this back at, let's make it maybe 80%. Run the simulation. Now we've got a fast extend and a very slow retract. Okay, so those are useful components for controlling the speed of actuation. Okay, the last variation, we're going to add another limit switch on the retract side. So we should get a reciprocating motion. When it extends, it's going to hit this limit switch, and that's going to push air into the valve to make it retract. When it retracts, it's going to hit another valve and push the cylinder the other way, so it'll extend. So it should keep just going back and forth. So again, I'm going to just make a copy of what I've got here and scroll down a little further. Just paste the circuit. And I'm going to just delete some of these lines. We'll draw some of them back later on, but I just want to make some room for the second limit switch. So we're going to use the exact same component. Let's see. Copy, paste. And we'll paste it right there. I have to put in another exhaust port. On this one. And so now I've got to get this out of the way for the time being. Might as well get rid of all these lines because they're just in the way. I'm just going to move this off to the side. We're going to be using that later in a different way. So now I'm going to hook the output of the extend limit switch back to the port that will cause this to go to the retract position. And now I want to connect this one over to the extend position. The only thing I'm missing is I need to have this port connected to compressed air. So I'm trying to think the best way for me to do that. I'll tell you what, I will. Okay, so I'll draw that in from here. And then reconnect this. Okay, so I've got compressed air coming into port 1 of each of these. So when it flips to the other position, it's going to allow that to flow out of this port and control the valve. So the only thing left to do is, rather than having compressed air on 100% of the time, I'm going to use a valve to turn the air on. So let's bring this one over. I'm going to connect compressed air. First I'm going to rotate it. Connect the compressed air to here. Connect the exhaust to the exhaust port. And then tie it in here. So that will be the compressed air line. So push button would be something that you'd have to hold your finger down the whole time to keep the compressed on. We want to change that to a valve that we can switch to the on position and switch it back off. So down here near the bottom is a symbol. That's the symbol for a valve, a 2-position valve. Now you notice that it moved into its default, its energized position. So what you can do is double click, and you notice when you're at this point, the symbol up in here is moving back and forth. So wait for it to move to the position you want and then click OK. So I want it to be in that position. So just click OK. All right, I think we're all set. Let's give it a shot. Turn the simulation on, and there it goes. Now I had adjusted the valves, the throttle valves, so that the retract is very slow. You can play around with that. All right. And if I flip the valve off, it'll just stop wherever it was. Okay, I hope you enjoyed the demonstration. Good luck with the lab. It should be kind of fun to get these circuits going once you get through the learning curve of learning how to place and connect lines and all that. So I'll see you in the next demo.